If you are new to balancing reactions, I recommend you watch my video on balancing simple chemical reactions first before watching this video. Balancing gets a bit more difficult when you add in polyatomic ions. I'm going to use this double exchange reaction to demonstrate. Remember, the goal of balancing is to make the number of each element on both sides of the reaction arrow equal. First, take an inventory of all the elements on either side. However, if there are polyatomic ions present on both sides of the reaction, treat it as if it's its own element and do not count it as multiple different elements in your inventory. In this example, there is one polyatomic ion present on both sides of the reaction, nitrate. So when taking an inventory, treat it as a separate element and do not count the nitrogen and oxygen in nitrate. As a reminder, always multiply coefficients and subscripts. Implying that there is a 1 in front of each compound, there are 3 sodiums, 1 nitrogen, 1 lead, and 4 nitrates on the left, since the subscript 4 only applies to what is before it in parentheses. Notice how I did not count the nitrogen or oxygen in nitrate, since I'm treating nitrate as its own element. On the right, there are 1 sodium, 4 nitrogens, 3 leads, and 1 nitrate. Step 2 states to always balance hydrogen and oxygen last, but because there are no individual hydrogens or oxygens, since we're not counting the oxygen separate from nitrate in the inventory, we can skip this step. Step 3 says to add coefficients before each compound. Because all the elements are unbalanced, you can begin balancing any element of your choice. I often begin balancing the least common element seen. So in this case, I'm going to balance lead first. By placing a coefficient of 3 in front of PbNO3,4, I've changed the number of leads to 3 on the left, while also changing the number of nitrates to 3 times 4 equals 12. Lead is now balanced. By placing a coefficient of 12 in front of NaNO3, I've changed the number of sodiums and nitrates to 12 on the right, thereby balancing the number of nitrates. By placing a 4 in front of Na3N, the number of sodiums changes to 12, and the number of nitrogen changes to 4 on the left, which balances the remaining element. To double check, there are 12 sodiums, 4 nitrogens, 3 leads, and 12 nitrates on both sides of the reaction. Our last step is to rewrite the reaction equation with the correct coefficients. Our reaction is now balanced. For more help with chemistry, subscribe to Chemistry Ninja.